Okay, here are your 2-2 notes. I purposely skipped 2-1. It's a lot of things that you go over as a freshman, and it's something that we could quickly just kind of talk about in class if you had questions. So hopefully by the end of these notes, when you go to start your homework, which is at the end of this video, you're going to be able to fit a regression line to a scatter plot, find and interpret correlation coefficients, and make predictions based on lines of best fit. Fit a regression line to a scatter plot, you're pretty much just going to have the calculator do that for you. This one will kind of be interpreting slopes, what's on top and what's on bottom of the fraction. Making predictions based on lines of best fit is pretty much putting in an x value and seeing what you get for a y value when you calculate that out. Alright, so here's your vocab. There's not too much for this section. A line of best fit, it could also be called a linear regression line or a least squares line. You'll definitely see a lot of line of best fit or a linear regression line. So a linear regression line is a line that best fits the data given. I'm going to say the data points, which is the same thing. Hopefully you write smaller than I do on this. Data points on a scatter plot. I don't know if you remember what a scatter plot is from way back in the day. Here's an example of a scatter plot up here. So it would just be like a graph. A lot of stuff we deal with will be in the first quadrant, positive x's and positive y's. So a scatter plot is when you, in real life, when you grab a bunch of data, it's not always this perfect, nice line like it is in your math books. Let's say, like we're going to do a problem where they are plotting the temperature and how many bottles of water this woman sells in her like little stand in the zoo or whatever. So if the temperature is your x, right, normally as the temperature increase, you'll also sell, say this is your bottles of water, you'll sell more bottles of water. So she plots all this data, and then it's our job to find a line of best fit, a line that will go through most of that data so she can make predictions about how many bottles of water she should buy or bring with her that day, depending on the temperature. Alright, so domain and range are back from freshman year 2. Your domain are the x values for the inputs. And your range are the y values or the output, what comes out of the function. This last one, a correlation coefficient, it tells you how good this line is, how good it represents the data points. This red one would be a pretty good representation of those data points if we had a graph that looked more like this. I know this looks so random, but sometimes that's how data comes out, This would not be a good fit. I have all these crazy pieces of data. This would not have a high correlation coefficient. It would not be a strong correlation, okay? This would be a strong correlation. So a correlation coefficient is a calculation. It's a number that the computer or your calculator will give you. There's a lot of me to write there, so I'm going to get rid of this. And that number is going to be hopefully really close to 1. That's what you want to happen. If you have a correlation coefficient of 1, the data fits the line perfectly. Your computer or the calculator is going to use R to represent a correlation coefficient. That's what you're looking for. It is used to judge how closely a line fits data. Oops, sorry. Okay? So a strong correlation, you're going to have R values that go from 0.75 to 1, or negative 0.75 to negative 1. Positive and negative correlations, just talk about if the data moves in the same direction or not. We can talk about that more later. You just need to know that the closer to 1, the stronger the correlation. A weak correlation is defined as anything as 0.3 or 0.30 or lower. So 0.30 to 0 or negative 0.30 to 0. A moderate correlation is anything in between. Okay? Why you need to know this is because in your homework, and I'm going to ask you to interpret correlation coefficients, and this is what you'll have to do. If it's between 0.75 or 1, you'll tell me it's a strong correlation, things like this. So this would be a strong positive, right, because it's positive numbers. Strong negative. This would be a strong, a weak positive. This would be a weak negative. Okay? Alright, moving on. I'm going to pause this for just 1 second. I need another window open. Alright, I'm sorry about that. So you either need to have a pretty good graphing calculator at this point for statistics, or I would recommend just going to Desmos on the internet. So I've just Googled that, as you see. So I'm going to go here. For example 1 in your notes, they're asking you to come up with a linear regression line. It sounds really fancy, but in all honesty, you're just going to be following some instructions. Oh, I'm sorry. That I've kind of printed here for you, so that should be okay. Alright, so when you're doing with the Desmos, you're going to go here, and you're going to go to the little plus. You want to add a table. If you see in the notes that I've given you some data up above. Oh my goodness, I'm sorry. Alright, so there's your data. And I'm just going to plug that in to the table here. So 6502, remember your x values come first. 71, 133, 79, 144, 80, 161, 86, 191, 86, 207, 91, 235, 95, and 237, 100, and 243. Alright, just so you have some context, these data points were taken from a problem in a previous section. And what it is, just like I said before, it's somebody recording what the temperature was. So this is the temperature, and how many bottles of water they sold that day. So on a 65-degree day, she sold 102. On a 71-degree day, she sold 133 bottles of water. Okay? So right now, I've just entered all of that data from the data points. And then, see there's another spot down here. I should tell it that I'm pretty sure this is linear data, and for this section, it will always, for right now, it will always be linear. So I'm going to go Y1, and to get that little subscript of a 1, I just hit the 1 button. Desmos does that automatically. And then you want the little kind of like approximate thing. So I'm going way up in the left-hand corner of my keyboard to get that symbol. And then it's going to be mx plus b. So m, your x has to have a subscript of 1. And then plus b. As soon as I type that in, you see all this data that the computer gives you. So what this means for us is that's the linear regression line for this data. So you're normally talking in y equals mx plus b. Sorry, I had too many of these things going. So it's normally y equals mx plus b. That's what we just put in. That's what we asked it to fit. And all you have to do is put in this n and this b. Here's your n, here's your b. So when I'm doing an equation, I'll always have a y equals something x. So my n will be right there. It's 4.4. I'm just going to kind of round. And my b is right there. It's a negative. So I'm going to go subtract 187.67. I know it's coming in the future, so I would also highly recommend just kind of jotting down your R value so you don't have to come back. So my R value here is right there, so it's 0.972, just so I have it, okay? Alright, so we're going to go on and we're going to do the next example in the same exact way. So we don't need any of this. So your first step, remember, is to just plug in that data. So here, I'm going to get another table. I don't need this stuff anymore. So here's my table. My first x is 1, and my first y is 56. And then followed by 2 and 45. 4 and 20, 3 and 30, 5 and 9. So I literally just copied those down from over here from this part of the example. Alright, my next thing is to tell it that I want something to be linear. So y1 is about mx1 plus b. It's mad at me. Alright, so all I did is I closed everything out and started new, so it was telling it that I want this table to be red. Okay, so here again is my m and my b. So all I need to do is put that information in, so it's always going to be y equals, right now. My m is negative 11.886, that 6 will bump the 8 to a 9. So my slope, my m, is negative 11.89. Oh, that's an ugly 8. And then x, and my b is a positive 67.686. That last 6 will bump that as well. So plus 67.69. That's my regression line. Again, because I know what's coming, I'm going to just write down r, and I would suggest you do the same. So your r is negative 0.998. That'll save us some time later. Right, I got the r from right there. You don't need r squared. Don't worry about it for right now. Okay? So we can be all done with the decimals for right now. Alright, and we would like this to be maximized. I'm going to get rid of all of the writing. Alright, so on the next example, I want you to interpret the slope and y-intercept in context of the problem. Remember, this is the woman who's running the kind of concession stand, and she's selling bottles of water. From before, we know that my equation is y equals 4.44x minus 187.67. It's asking us to interpret the slope. Your slope is in front of x, so it's 4.44. I don't know if you remember, but when you're doing the slope, it's the change in the y value over the change in the x value. For this problem, when we looked at the data, the x was the temperatures that she recorded that day, and y was the number of bottles of water. So when they ask you to interpret this, you just kind of put this number in for this equation. And all I mean by that is take the whole number that they've given you, I shouldn't say whole number, I'm sorry, take the number they've given you and put a 1 on the bottom. That's how you make something into a fraction. So if this 4.44 is the change in y, or the number of bottles, this would mean that Rachel, so 4.44 bottles of water for every 1 degree increase in temp. And I'm saying increase because both of these are positive numbers. So the bottles of water, she must sell more bottles of water because it's positive, and the temperature must be going up because it's positive. So the thing is, this is great in the math world. In real world, you can't get 0.44 bottles of water. So if you wanted to put a 5 here, I'd be fine with that too, either way. Down here it says about how many more bottles, oh, I said 5. I'd be okay with 4 too, sorry, got distracted. About how many more bottles of water will Rachel sell if the temperature rises 2 degrees? Depending on which one you picked, your answer would be different. So let's be safe and just plug the information back into the original equation. So y equals 4.44x minus 187.67. They're saying that the temperature is going to rise 2 degrees. Okay, that's hard because we don't even know what the original temperature was. So if you said 4 bottles of water and it's rising 2 degrees, are you okay? She's going to sell 8 more bottles of water. And if you said 5, you're going to say she's going to sell 10 more bottles of water. Either one's okay. I went with 8. If you want to say it's about 9, I'm okay with that too. All she has to do is make an estimate so she knows how many bottles of water she needs to bring. Okay. Example 3, it's making predictions based on a line of best fit. Honestly, you kind of just did that. So it says Rachel's stocking her concession stand for a day in which the temperature is expected to reach 106. How many bottles of water should she pack? So you still have that original equation. Y equals 4.4x minus 187.67. They're telling you the temperature is 106. Temperature we decided was x, so when you rewrite this, you're just going to have y equals 4.44, and instead of the x, you're going to put in 106 minus 187.67. I'm just writing out the rest of the equation. If you put this into your calculator, you are going to get y equals 282.97. Remember, y stands for number of bottles of water she's going to sell that day. So if I was Rachel, I would make sure I brought at least 283 bottles. That would be my final answer, since I can't sell partial, or I can't bring a partial bottle of water. This is going to be the same exact thing, only they've changed it to 83 degrees. So I'll use that same equation, but instead of a 106, I'm going to put in 83. So y equals 4.44 times 83, that's an ugly 8, sorry, minus 187.67. And if you do that out, you are going to get 180.85. So again, I'd bring 181 bottles of water. Right? I can't have 0.85 of a bottle of water and sell it at least, right? Like, that would be someone like took a drink off it or something. That would be gross. Okay, so I'll get rid of this and we'll go to the next section. The last example. Alright, so I tried to kind of make this table for you here so it was a little bit easier it's easier to do for you, hopefully. So this is about the R's that we talked about earlier, and hopefully you kind of wrote that down. You have somewhere to reference them. So remember, if you have an R value between 0.75 and 1, it's strong. Depending on the sign, it's either negative or weak. If it's 0.30 or less, it's weak, and again, depending on the sign, it's positive or negative. So find the correlation coefficient to the nearest hundredth for the linear regression for Rachel's data. If you remember, we wrote that down, right? We've already done that in the Desmos calculator. It was there when they gave us the equation. So we have an R of 0.97. So you need two pieces of information. You need to know if it's positive or negative, and here it's positive. You need to know if it's 0.75 or higher, or is it 0.30 and lower. In this case, you'd be looking here, right? It's higher than 0.75, so it's strong. And it's a positive number, so it's a strong, positive correlation. The strong means that the equation we came up with is a strong indicator of future things, right? It's a good indicator of what's going to happen for the temperature and number of bottles of water. Positive means that both things are changing in the same direction. So I mean by that is, as the temperature increases, the number of bottles of water is also increasing. They are both increasing. That's what positive means. Down here it says find the correlation coefficient to the thousandth for the linear regression for the data in the second part of example 1. Again, we wrote that down, so we know that R is negative 0.998. Alright, so ignore the sign for a second. 0.998 means that it's strong, right? It's really close to 1. And it's a negative correlation because it's a negative number. And there you go. Interpret the correlation coefficient, strong, negative. Interpret the correlation coefficient, strong, positive. That's all you need to do for that. Just so you don't forget, your homework is right underneath that. Your homework is number 4 and 7 on page 73. Please do not do E. For your homework check next class, I just did one of these. The questions are the same. I just put in a different table of data. If you have any questions, let me know.